With over 100 trillion objects stored, that's a lot of data. And securing that data is critically important. My name is Mike Milner, and I'm VP of Cloud Technology at Trend Micro. I want to thank you all for joining me here this morning. In my role, I have the privilege of talking a lot with our customers at Trend Micro and understanding their needs in the cloud, where their pain points are, and making sure that our products are aligned and can help them stay secure in the cloud. And today I want to talk about security in S3. So first, S3 itself. I want to talk about its evolution and how it became such a foundational service of so many other AWS services and so many of our customers' applications. And then a bit about how security works in general in the cloud and S3 in particular, and why S3 has provided some challenges with security in the past. And then I want to look through some specific customer use cases. As we built out our capabilities in Cloud One, how we addressed those customer pain points, address those customer needs to make sure that we built a secure product and help our customers be secure as well. So first, S3 itself. S3 was launched way back in 2006. That's like forever in cloud years. It was one of the first AWS services. Maybe a little bit of trivia here. Does anybody know what the first AWS service was? SQS, that's right, that's right. And you can see both of those have become building blocks of so many other applications and services because they are simple. They're foundational. Data that goes into S3 is durably stored. And that sounds simple, but it's actually quite complex to make that a reality. But they've managed to do that and keep S3 simple, low cost, and extendable. And if you look at durability, what does that actually mean? AWS looks at it in terms of this durability number there, and if you can't count them, that's 11 nines, which is pretty amazing. What that means, if you kind of look at the numbers, is you could store, I think it's 10 million objects in S3, and if you left them there, it would take 10,000 years before, on average, you might lose one of those objects. Given that humans, our species, have really only been writing things down for maybe like 5,000 years, that's pretty impressive. And it's really important because you need to have trust that if you put something into S3, it stays in S3. Because if you don't have that trust, then you need to keep a backup, an alternative, a box full of paper records in a warehouse somewhere. And as soon as you need that alternative, then you kind of lose the benefits of S3 itself. So making sure that the service is durable and that the objects you place in are still there is critically important. AWS has done an excellent job here. Now these durability numbers, the 11 nines, that's only part of the story. There's also availability. You know the objects you put in are going to be there, but are you going to be able to get them out when you need them? And for that number, AWS talks about availability as 4 nines. Not as impressive as 11 nines, but it's still, as a IT service, very impressive. That means less than 1 hour of downtime per year. And one thing I've always liked about AWS is they give you the building blocks. So if 4 nines availability is not enough, AWS has their global network of data centers. So you can distribute your objects, replicate them into other regions. So now if one region does go down for that, less than 1 hour per year, you have the ability to use other regions. And AWS provides services to make that easy, this Amazon S3 replication. So again, you kind of have these building blocks, these layers that build up to make this a reliable service. What if you delete objects by accident? That's definitely a concern as well. So again, layered on top of S3 is S3 versioning, the ability to configure S3 so that older versions of files are retained if they're deleted or modified. Again, giving you the tools to build the durability and availability that you need for your application. They even go further with more extreme requirements. S3 object lock. So if you have data that you must retain for a certain period of time for regulatory or legal compliance, or God forbid you have a lawsuit and you need to hold data until it can be investigated or used in an investigation or something like that. S3 object lock, again, layers on top of versioning to give you those even more powerful controls. Again, all building that trust in the platform that what you put in will stay when you want it to stay, and it will go away when you want it to go away. This is critically important. But it's only part of the overall story, because yes, you can put lots of data into S3 and it will keep it here for 10,000 years, but nobody's going to do that if it costs a fortune. So the next main point I want to talk about is the cost aspect. Right now, in I think US East, they clarified Ohio region, about 2.3 cents per gigabyte per month. If you look at the price at launch, it was 15 cents per gigabyte per month. The reduction in cost, I think, is one of the most interesting things here. AWS is aggressively reducing the price, the cost it takes to store data in the cloud, and giving you options as you store more higher volume tiers. If you need less availability or slower response times, actually giving you the option for cheaper storage by going things like infrequent access, or going even longer term retention like S3 Glacier Deep Archive, which can reduce costs all the way down to really less than a penny per terabyte per month, which is truly amazing. Durability plus low cost means people are putting a lot of data in S3, which is why security is so important. The last attribute of the service I want to talk about here is the simplicity itself. And you knew this was important for AWS. It's actually in the name, Simple Storage Service. Because at its core, S3 is really just a key value store. It's just where your value can be 5 terabytes large. And it's very impressive that over the years, from that launch in 2006, they have added a lot of capability to S3. But at its fundamental level, they've maintained that simplicity of putting objects in and getting objects out. Now, they've given you lots of new ways to do that, so many that I had to write them down here. Getting data out. You probably are familiar with one of the early options for actually hosting websites in S3. And it's interesting for this conversation that hosting websites in S3 is taking your S3 objects and you're making them publicly available on the internet to your website. But that has also been the source of quite a few problems with S3 security over the years. And I'm going to talk about some of the ways that AWS has addressed that and some of the ways that we've helped our customers address that with Cloud One. Getting data out, accessing it with services like S3 Select, Glacier Select, being able to query data, use it in the cloud, again, have made it even more common for customers to have a lot of data in S3. Services for filling those buckets with storage gateway and data sync to get your on-prem data into the cloud. For legacy transfers, there's transfer family for FTP, SFTP, that kind of protocol. And one of my favorites, remember the reInvent where they drove the big 18-wheeler container onto stage? The AWS Snow family for actually shipping data in the mail when you have so much that transferring it over the network is too slow. All of these capabilities are built into the platform, but they still maintain that base simplicity of putting objects in and getting objects out. So now I want to shift gears towards that security angle. What does security mean for a service as simple as S3? Well, we can't really talk about any security on AWS without talking about the shared responsibility model. I'm sure most of you here are familiar with this model. What it's basically saying is that AWS is going to take care of a lot of the security aspects in the cloud, the security of the cloud itself. So on my durability slide at the start, those foundational things of durability, availability. AWS is taking care of that for you. That's their job. But on top of that, it's up to you, the user, the customer, to use the tools that AWS has given you to make sure that you're using the cloud securely, security in the cloud. And they even go more specific for S3. This is the shared responsibility model specifically for Amazon S3. And because the service is so simple, you can see that the customer portion is much smaller. There's not as much that you need to worry about. That's one of the things that makes it so foundational. AWS does so much for you. But there are a few key things in there I'm going to talk about. First is the customer data itself. What data are you storing in S3? AWS doesn't help you with that. It's up to you to make sure that that data is not going to cause you security issues. And then the other aspect, all of those configuration options that AWS gives you, all of the different ways you can configure S3, configure your buckets, access permissions. That's, again, all up to you. So I want to expand on this customer portion. What does that actually mean? And I've grouped them into 6 broad categories. And you can see the first 5 are actually all around that configuration aspect. A lot of the cases where AWS S3 has been involved in a data leak, it's almost always because something was misconfigured. So much so that misconfigurations is the #1 source of leaked data. So the first point here, it's up to you to make sure that you configure access rights for your S3 buckets and objects in S3. That you've defined the least privilege that your applications need when they access your objects. It's up to you to turn on those security controls, turn on encryption. It's up to you to make sure that every one of your buckets is following your company's governance policy. And for pretty much everyone, encryption is a must. AWS gives you the tools to manage the data in the cloud by tagging resources, so you know what that data is, how it's classified, how important it is to you, what risk it faces. That if you need that versioning, you've got it turned on and configured correctly. That the applications that shouldn't be able to change old versions aren't able to. That least privilege access. I mentioned this earlier, the public access, a common source of data accidentally being made available to the internet. If you don't need your information to be public, make sure that you've turned off public access. AWS has actually enhanced S3 over the years to help even more against this type of problem, where if you have accounts that don't need any public access, you can actually turn that off very broadly at the account level, so that none of the S3 buckets will have public access. Again, more controls, more configuration that you need to set up. And then number 5 there, once you've got objects in S3 and you've got your permissions hopefully configured down, and your application is now using that storage, make sure that you can track how it's being used, audit who's accessed what, by turning on logging for all the data access, and turning on logging for all the configuration changes. Then finally, number 6, which I'll spend even more time on, is that data level security. What you put in S3, making sure that it is not going to introduce security risks to your applications. And as you think about these requirements, there's a few questions that you need to think about. You can look at those requirements, and you might have a pretty good idea how you need to configure your infrastructure, how you need to configure your buckets to make sure all those things are done and set up correctly. But how do you validate over time, over the life of your application, that the configuration stays the way it should? How do you validate that as your applications evolve, your new changes also follow that policy? And when changes are made, do you actually have tracking and visibility of that? Can you tell and comply and audit why something was changed, when it was changed, who changed it? And the people making the changes are the development teams, the people writing applications. How do you make sure that they're aware of the security policy, aware if they've accidentally introduced a misconfiguration change, making sure that that policy is available and enforced for everyone? And then how do you protect against malicious content in S3 in a way that doesn't interfere with all of those benefits of S3 we talked about earlier, so that you can still take advantage of the massive scalability and flexibility that S3 gives you? Okay. Those first 5 boxes, they're all related in that they all have to do with the control plane of AWS, the configuration options. So let's talk about that first. How do you make sure that the resources you put into the cloud are configured securely? Well, thankfully, this is not an isolated issue. It's not just an issue with S3. It's actually all of AWS. Every resource that you create in the cloud, you want to make sure it's configured correctly. And the industry has created a whole set of tools called Cloud Security Posture Management, CSPM. And this has evolved over the years, but effectively, it's a tool that can look at your cloud environment all the time, constantly monitoring, and every single resource in the cloud, it's looking at that resource and making sure it's not misconfigured, that you haven't introduced security vulnerabilities, that your cloud resources are following your corporate policies so that you can maintain your compliance. And as these tools have evolved over the years, it's followed industry trends as well, where you're not really going into the cloud and configuring things manually. Most organizations, as their maturity in the cloud grows, are using infrastructure as code. Infrastructure is defined in code. So moving that CSPM further towards the developers becomes important as well. So tools that can actually plug into that infrastructure as code pipeline and make sure that that's scanned, so that you can fix issues earlier in your development process, saving time, saving money, and keeping your developers happy. Nobody likes getting told after a whole development effort that, oh, you didn't configure that correctly. Move that earlier in the process so that developers are aware of these policies, aware as they're writing applications that they're following the policies. Okay, so let's look at what this actually would look like in practice. I've got a sample application here. And you can see mobile devices on the side are sending data into the application. The application is processing that data, and then it's serving out some results of that application back to the users. And this architecture is pretty typical of a lot of different use cases. I mean, at the simplest level, this could be uploading an image and then making that image available to other users. But it could also be very complex. That processing could be leveraging all of the resources of AWS. This could be spanning days, weeks, or years processing, extracting information from that data. So you want to make sure that the infrastructure you're building is secure. So we talked just a second ago about that cloud security posture management. What does that look like for our application? Well, the first thing we need to think about is, how did that application get in the cloud? Where did it come from? If it's a prototype, maybe somebody's just logging into the console and setting things up manually. But as I mentioned earlier, that infrastructure as code concept means you want to have a bit more control of what's going into your cloud. So we want to introduce a pipeline. And you can see here, every pipeline follows the same basic concept, that you've got code stored in some kind of version control. And as that code is merged, built, reviewed, it's going through that pipeline. And from a security perspective, this is really great because the pipeline gives us the right places, those right hooks to introduce security for our users, where you have an opportunity to scan that infrastructure as code, look for those misconfigurations before they ever get deployed, before your bucket is accidentally made public to the world or some other misconfiguration. And importantly, it's closer to the developers. It tightens that loop. So if there is an issue, it's going to find it sooner. Probably, depending on how you've set it up, before that code ever gets merged into your main branch. Or possibly all the way to the developers, tying directly into their IDE with an IDE integration, telling them as they type their code if they're introducing any weaknesses, allowing them to fix it before they even commit their changes. And importantly, it adds structure around how code gets deployed into the cloud. So you can set up controls that code must be reviewed before it can get deployed. It introduces those opportunities for compliance. You can see a few standards on the side there. All of these compliance standards require a separation of duties, that the person who writes the code is not the same person who deploys and manages the code. And all of these things, these requirements, the compliance, if you're trying to move fast in the cloud, they can sound quite restrictive. But with some smart pipelines, you can actually make that move much more quickly, where a developer writes code and somebody else reviews it. Already, you've had a separation there. Two people are now looking at that change. Maybe somebody else deploys it, or automated deploy, but it gives you the opportunities to set that up. And then if we apply this pipeline concept to our application, you can see now all of the application code is going through the pipeline, and then it gets deployed. And on the running instance, the instantiated application, you've got the runtime CSPM tool constantly monitoring those resources. So if anybody does log into the console and manually change something, manually tweak a configuration, that's going to be detected by the CSPM tool. Or if, you never want to hear this, but if an attacker managed to get access to your environment and they're making changes, creating new roles or interfering with your infrastructure, that will get detected as well. And now what you've built is your application, just like before, but now it's got some security structure around it. You have confidence that new changes coming in are maintaining your governance and compliance. You're not introducing misconfigurations. And the code that you've already got running is compliant. And by monitoring those two different aspects, the changes, but also the current state, it also gives you a lot of flexibility as your requirements change. Maybe there's a new compliance standard you're interested in. You can set that up in your running CSPM tool, and it's going to tell you pretty much a gap analysis. What's different? What do I need to be? Where's my application now? And then you can prioritize the changes to the application to bring yourself up to that new compliance standard. It gives you the visibility of what's going on in your cloud without having to be the developer writing the code. It gives the security teams that visibility, and it lets developers continue to move quickly. And this really gives you that first 5 boxes that I talked about earlier, all those configuration options, avoiding the misconfigurations. But now I want to dive in to that last point, the content. So we've got our application here, and you can see it's actually written using serverless capability. It's all API gateways, Lambda functions, step functions. It's designed to take advantage of AWS's scalability. It doesn't matter how many users are using this application, it will scale very easily. So when we talk about content security, looking for malware in that content, it's pretty important that whatever solution you put in for content scanning has those same attributes, that it scales well, that it's not going to interfere or slow down the application that you've built to be fast and scalable. So for this application, this is where, at Trend Micro, we start working with our customers. We want to make sure that we're solving their pain points. And in this case, for some particular customers I'll talk about in a second, we wanted to build a solution that also leveraged Lambda to take advantage of that scalability. And if you look at that same application, but now with content scanning, you can see there's actually not that much different. The data is still flowing in the same way. Images or whatever content are still being uploaded directly to S3. But what we've introduced in that shaded box is a complete solution for scanning and managing that content security. And you can see in this case, it's set up as a kind of a good, bad quarantine setup. So every object that gets uploaded to that first bucket is going to get scanned for malware. And then based on those scan results, it's going to either be promoted to the good bucket, and you can see that triggers the same notification and processing that the application had before. Or if it contains malware, it's going to be sent to a quarantine bucket where it can be actioned separately. But importantly, it's not triggering all the rest of that downstream workflow, that processing. You're protecting the downstream processing from handling potentially malicious files. Now, as we were building this for customers, as I said, that has a lot of nice attributes. It's scalable. We're using Lambda. It scales just like their application scales. But there are some potential limitations with using Lambda we had to overcome. The first is Lambda is designed to be transient. It spins up fast, does its work, goes away. But it also is a quite limited environment. In terms of disk capacity, in a Lambda function, you've only got 250 megabytes or so. So a kind of initial pass of this as we were developing the product meant that we had this limitation of 250 megabytes. And that's pretty unacceptable, right? So we had to look at maybe alternatives. Could we use infrastructure or something like that? Would we still get the attributes that Lambda gives us? But when you look at an infrastructure alternative, say with EC2 instances and EBS volumes, there's a lot of disadvantages. You now need to take files from S3 and bring them into an EC2 instance. You've got an EC2 instance you need to maintain with patching and maintenance and security. You're trying to get away from that by using Lambda. An EC2 instance is running all the time, even if no files are being uploaded, no content is being scanned. So it's more expensive. And large files, moving them over the network onto EC2, scanning them, moving them back, can be quite slow. And for one of our very early customers, Fox Sports, this was pretty unacceptable. You see this big truck on the left with 4K. If you're not into video, 4K, ultra high definition, high dynamic range, what that means is enormous files. And they roll these big trucks up to football games. All the high resolution imagery, the video from a game is all coming into this truck. And they actually use S3 to send that content through to their distribution networks. And this is a lot of data going through the system. And it's very important for Fox that that data is secure, it's sound, it's not malicious. Because that data gets processed and distributed to many, many kind of post-processing actions. So we worked with Fox on Cloud One file storage security to help them solve their needs. And the major stumbling point was this file size limitation. How do we scan files over 250 megabytes when we're dealing with video files that are tens or hundreds of gigabytes? And it's television, so it has to be fast as well. So we knew that infrastructure wouldn't work. we wanted to use Lambda. And what we've been able to do is actually take advantage of, again, some features in S3. S3, you don't actually have to pull the whole object to access its content. You can actually just ask for a range of bytes. And when you're scanning files for malware, you don't actually need to scan entire files. Usually there's just a few key areas where malicious content can be placed. So with our Lambda function, we were able to just pull the chunks that we needed from S3, scan those within the Lambda function, pull additional chunks if we needed it based on that initial analysis, and give scan results that are extremely fast and scalable along with S3 by leveraging Lambda. So that Fox had confidence as those video files were being processed that malware wouldn't interrupt or interfere with the broadcast. Imagine watching the football game and missing a touchdown because the screen goes black. Some processing component failed. We give them the confidence that that's not going to happen because of their content. The next customer I want to talk about is in the education space. And they're not quite as flashy as Fox Sports. But when you think about it, education is also a critical kind of safety component. Everyone says, well, think of the children. But that's true. You need to think of the children. Think of the students. And this education use case had some specific requirements. The content tended to be longer lived. A teacher or educator would prepare lessons, and they would often be used again and again with different classes. So as teachers were uploading content, their focus is on educating their students. They're not IT experts. There's a chance that maybe their workstations have malware on them, and maybe some of that educational content they're producing could be carrying that malware. So everything we just talked about, it's going to scan these files as they get uploaded, so that we can be pretty confident that malware's not getting in, or at least malware that we know about. And I don't know how much you know about malware research, but malicious content is always changing. Attackers are always adjusting the way that they write their malware. They're writing new malware. They're packaging malware differently. And what that means is our understanding of malware evolves over time. So there's a chance that files could be uploaded that today maybe we don't know that they're malware. We haven't analyzed them yet. But maybe through our research and automatic analysis, we'll know tomorrow that they contain malware. But this education content, this long-lived content, we don't want, a year from now, these students to be downloading this content and getting those files that we now know are malicious. So again, working with this customer, we said, how can we address this issue? And the timing was good on this one. When we first started working with them, we thought, okay, well, maybe we could scan the buckets periodically. But I don't know if you've ever tried to do something like that, but it feels very wasteful because this content is sitting there in the bucket. And how often do you scan it? Every day or every week? Do you have to spend all this compute to scan this content where most of it's going to be fine? But do you have to keep scanning? And it just didn't feel right with the model that we had for Cloud One. It wasn't scalable. It didn't feel cloud native. So we started working with AWS on this. And they introduced a new capability that we launched with them called S3 Object Lambda. And if you're not familiar with it, it's pretty cool. What it allows is a Lambda function to be invoked when an S3 object is retrieved, when you get an object. And that Lambda function has an opportunity, before the object is returned, to scan or alter or do whatever it wants to do with the object and then return it to the user. Or, in our use case, block that content. So now going back to our education customer, Now we had the opportunity to say, okay, any file that gets uploaded, we're going to scan it immediately. And if you want it, every file that gets retrieved is going to be scanned as well. And importantly, it's scanned with the most recent virus definitions at time of retrieval. So if there is new understanding, we now know that this file contains malware. As soon as somebody tries to access it, it's going to be scanned, it's going to be detected. So now we've closed that loophole and we've avoided all the hassle of bulk, repetitive scanning. Now files are scanned when they're uploaded and scanned when they're accessed. Closing that loophole, solving that problem for our education customer. It's always nice when Jeff Barr is talking about your product too. Then the last customer I want to talk about is a finance example. And this isn't unique to finance, what I'm going to talk about, but it's the idea of data sovereignty, data control. Your data is your data, and AWS gives you very strong guarantees of where that data goes, how it's controlled, who accesses it. And in finance, it's a heavily regulated industry. So you can't take financial data from the US and just send it to Europe or vice versa. That just doesn't fly. So our customers are in general very conscious of where their data goes. And a lot of other solutions for malware scanning that are kind of out there and available, they require you to send them a file. Hey, scan this file for me. And maybe they've got an API to do it, but you're still sending that content somewhere else. And that means it's no longer in your control. And for some of our customers, that's untenable. They can't do it. So we also needed to give them those guarantees that the files that were being scanned weren't leaving their environment. And if you look at the architecture that we've built for our file storage security, this is what gets deployed when you deploy file storage security in your environment. And you can see these components are all serverless as well. We have Lambda functions, and you can see the general flow. We've got two components, a storage stack that sits in the account of the S3 bucket that you're protecting. And we've got the scanner stack. That's where the actual scanning activity happens. And that can be in the same account, or it could be in a separate security account. You've got the flexibility of where that's deployed. But the key thing, though, is both of these are deployed in your accounts. Your file content isn't being sent to Trend Micro. We're not moving it into our cloud. It's staying in your cloud. And for heavy regulated industries, this is critically important. Because if that file loses or leaves your environment, you no longer have that same guarantee that it's under control. So as we architected this, and you can see the basic idea how it works is when a file gets added to a bucket, it triggers a notification. That notification queues up a scan job through that original AWS service, SQS. And then the scanner stack will then retrieve that object using that byte range aspect, so it's not pulling the whole file, it's just pulling the parts that it needs, into a Lambda function that's running within your account. It's scanning that file, and then only the findings need to leave your account. Did that object have malware? Well, you want to see that in your Cloud One dashboard. The content stays within your account. And the nice thing here is S3 isn't really just a file storage service. It's a component of your applications. You don't want to just put files in and take them out. Files go in, objects go in, and they trigger actions, they trigger workflows. So we wanted to give you the same extendability with our option. So as files are scanned, we also trigger notifications. So if you want to tightly integrate this capability into your applications, show a user information, context if a file gets rejected due to malware, you can actually subscribe to these same notification queues, this post-scan action. And in this architecture, this example, we're tagging files. So you can tag files and say, hey, this file has malware, this file's good. But you can also do whatever you want. You can do that quarantine bucket setup, move that file into quarantine, promote good files to another bucket. Or you can integrate it directly within your application. Pop up a message to the user and say, hey, you uploaded a file. We detected it contains malware. You might want to look into that. It gives you the flexibility to build your applications with this capability. So kind of summarizing everything we've talked about, those two tiers, your configuration, that control plane, making sure that your systems are configured correctly, you're avoiding misconfigurations, critical importance. For your data security, Cloud One file storage security, we talked through these benefits. You're probably all reading them now, so I'm not going to read them out loud to you. But really, I want to just hit home that AWS has built a platform that has these key attributes. And at the very start, I talked about S3 in particular, and the last bullet was the extendability of the platform. And it's allowed all of this capability. And for me personally, that's what I'm most excited about with AWS, is that they give you the building blocks, the layers, the tools to build upon, to extend, to get all the same benefits of the cloud, of that scalability, those resources, the massive infrastructure, just by pulling these pieces together. And in Cloud One, this is really our mission. We have all the capability to help you be secure in the cloud. And we've linked that with all of the different AWS services that we can help you secure. And as you've seen in the architecture diagrams, we don't just help you secure your AWS cloud. We've built Cloud One with those same AWS components. So no matter what you're doing in the cloud, no matter what phase you are on your journey, Cloud One can help you secure your environment. Help you make sure that you're not leaving things exposed, that you're not putting your users at risk, that you're not risking downtime, that you can secure your journey to the cloud. If any of this was interesting to you, we have a whole set of guided workshops where you can try all of this capability without having to mess around with your own accounts. Everything's managed. You can try this out, get a feel for how it works. There's no charge. And it's a really great set of content. So I encourage you, scan that. You can see the link down below. Take a look at it. Or go check us out at the booth where you can see demos of all of this functionality. I want to thank you very much for your time.